let's get into it. I won't, I have something on the CUBESAT background. I'm sure you all know about that, so I'm not going to go through that. Where it came from and what it was about, you can quickly read it if you don't know. But it, you know, it's really taken off. There are at least 40 institutes that are developing picosets or CUBESATs right now, and I tell you, the count sort of like will double in the next year at the way I'm looking at it. But anyway, how big is a CUBESAT? I think you all know it's 10 by 10. It's, roughly it's 1 kilo, and although some people will stack 2 or 3. And developers basically benefit from sharing information within the community. And I don't know where CUBESATs would be if it wasn't for amateur radio frequencies, because they just wouldn't have a life. Right, the objective of our project is to encourage innovation in amateur radio and to build technical skills. And if you look in the picture, you see the architect of Sunset-1, Golf Milne, who unfortunately is no longer with us. Tragically died of cancer a few years ago, but he was the one, the motivator of SO67 as well. Anyway, to encourage students to follow a career in communication and electronics through amateur radio, possible payloads, a voice beacon with basic telemetry transmitting satellite health, obviously, but we're looking this time of doing telemetry by voice rather than on CW or rather than any complicated way, because we visualized that if you use this project in a school, then having voice and using the dongle that AMSAT-UK is developing, you know, you really be able to expand that whole opportunity. We're also looking at a VU transponder, 2 meters and 70 centimeters down. We already have one in development that's going to be flown on one of the balloons pretty soon. It's a 30 kilohertz bandwidth linear transponder. A scientific experiment, and at this stage it envisaged it includes a receiver that will monitor noise pollution in the HF spectrum. But I mean, that's very much a debatable point, whether we're going to monitor HF spectrum noise or whether we're going to look at ultimately maybe doing a monitoring on the VHF spectrum to see what is what where. But that would limit it basically on obviously when the satellite receiver switched on and how much data we can handle on the CUBESAT. We haven't finalized this, and we have a design meeting to identify the payloads towards the end of August. So at this stage, you know, I was hoping that we would have gone that far, but we haven't. To involve as many radio amateurs and learners and students involved in the project team, that approach that we're looking at, I think it's a copy of FunCube, if you ask me. Each team will work on a particular aspect of the satellite, and they will be assigned their various tasks and so on. Then we believe very important is to have a non-technical team to cover the administration, funding, because we need to raise quite a bit of money to do the necessary thing, and that's not including the launch costs. But we hopefully will get government to fund that. Communication between teams through regular teleconferences. We find teleconferences or obviously Skype is very useful for that purpose. And education outreach to schools, because if you don't have a non-technical team that looks after these things, and we've seen this with so many other satellite projects, we have great ideas of selling it and involving students and schools, but if you don't have the kind of network of people that are actually facilitating that, it will never happen. So when will we start? Well, we launched the project at our symposium in March this year, and then we had a competition to select a name for the project. Closed a week ago. We got quite a few inputs from South America, the UK, all over the world. People have very strange ideas what a project should be called. Some real good laughs in there. Some of them went to the internet, and they looked for an English word, and then they asked the internet to translate it into Zulu. But the trouble is internet translations come out very funny. So some of the Zulu names mean something quite different. Not usable, that's for sure. Winning project name will be announced mid-August. We are meeting next week to look at about 100, 200, I think it's about 150 now of names that we've had. So yeah, we'll see. And A national link-up will be held later on this month to get all amateurs in South Africa that are interested involved in making suggestions for payloads, when then the AMSAT committee will make a final decision on what payload we will go for, and then of course the teams will be established. We already have some people working in the background to looking at as I said, a transponder is already in a prototype. There's someone now looking at how do we going to monitor the interference that we see on frequencies, and so that will be specified and spec'd, and I reckon by about November, December we should have like a full spec of exactly what we're going to do, and then have a time frame. Internationally, the national link-ups, how we do that, we use a teleconference center, and then those people in individual cities link their repeaters to the teleconference center. So on 2 meters you can talk throughout the country with one another to be able to discuss the inputs. So you get a lot of people involved in that. And that's one of the things we always criticize by saying that any organization always thinks that the committee decides what's going to happen, and we decided this time let's give everybody an opportunity. Needless to say that ultimately the committee's ideas normally are the better ones, but at least you give people an opportunity to feel they're part of the decision. Right, some ideas. The objective was to monitor the HF band primarily, first of all, over Southern Africa, and monitor interference sources. We have a lot of interfering sources. We don't have particularly good regulators, and even those countries that have good regulators don't have good monitoring stations. In fact, they're almost non-existent. So interfering signals will be recorded, linked to GPS data, so that hopefully we'll be able to identify the source and then see how we can deal with it. But you may have ideas. You may have ideas on that we shouldn't be doing that, but we should be doing something else. And really, we would welcome your input on any of those things. So drop us a line. There you see the email address samsat@intercom.co.za, and intercom spelled without an R and with a K. Everybody makes that mistake. Right, but I'd like to talk about another project that is more advanced at this point, and it's called Lalela. And Lalela is a round the world balloon project. It's a Zulu word for listen, and that is exactly what radio amateurs around the world are invited to do, is to listen to signals coming from a balloon traveling around at about a 22-kilometer height. Now, once at that height, the prevailing winds will drive it around the world, apparently, and they looked at plots and so on, and who knows where it will end up ultimately. This is what it looks like. It's one of the prototypes. It's very much like that type of mylar coated gold and silver that's being used for the solar sailing. And there's the guys whose brainchild it is and who's actually at this stage funding all the development. There you see it, and I'll talk a little bit more about, you see that funny contraption at the bottom. It actually spins and it actually generates the power, and through that it also generates the hydrogen that keeps that balloon going where it needs to go. Right, initial communication tests were carried out using 2 prototype flights that we sent up with ordinary small weather balloons on 14 megahertz. The results were disappointing because of poor antenna performance. In later developments we looked at 15 meters and 40 meters. And the power levels increased from a few hundred milliwatts to 1 watt, and much better results were obtained. And then the antenna is a wire trailing from the bottom of the equipment housing and is automatically electrically tuned to the correct frequency. So it's quite an interesting kind of development too, to do that. But it's worked so far very well. The original plan was to use Morse code to transmit the output from the GPS and other telemetry elements. But yeah, although it's still the most efficient form, there's still many people that we believe if you use this also as an outreach program, that Morse code is not the ideal. And again, we've opted for SSB voice. So obviously FM voice would have been better, but you know, there's a power problem there. So we're using SSB voice for that particular thing, and works pretty well. Construction, the balloon is constructed from a polyester material. As I said, it's coated inside with aluminium and gold on the outside. On the top is a hard plastic plate with which 3 weather balloons are fastened to provide a rapid lift. So when you launch it with some weather balloons to get it going fast. At the bottom, the balloon is a 40-meter round section that houses the miniaturized electronics and the lithium-ion battery and a small wind turbine, as you saw just now on the other picture. Total weight is only 243 grams, and the balloon itself is 1.767 meters high. It operates at 0 pressure and has a porosity of 0.02 grams per 24 hours. And the hydrogen generator can produce enough to maintain the flight for up to 600 days. So, you know, if everything goes well, it will be sending signals out for 600 days. Some challenges: being 21 kilometers or thereabouts up, it's necessary to stop the bearings from icing up, and the turbine, and then has a heater around its housing which slightly increases the temperature in that area, operating under the control of a sensor. And if the microprocessor from various readings detect an ice buildup in the bearings, it starts feeding energy from the turbine into the bearing windings to control the ice buildup. So basically we're using some of the available power to heat up the bearing to stop it from being iced up and obviously stop from operating. And just hope it works, because if it doesn't, it will just come down very quickly. Information transmitter: the GPS has been programmed to provide the coordinates as well as the elevation. The other sensors monitor the balloon pressure, outside temperature, ice deposits on the turbine, and to comply with international requirements, LALELA also includes a receiver to enable a shutdown mechanism to switch off the transmitter should it go spurious. Interesting, in fact, it actually destroys the whole package. But yeah. Come on.
That we have on the rig. Here we have our sensors, our battery, current monitoring, hydrogen generator, GPS to voice, and SSB transmitter, all controlled from the main microcontroller. The GPS gives us our location, latitude and longitude, our altitude. It has its firmware changed so that we can measure altitude up to 50 kilometers above the surface of the Earth. It gives us our direction and the speed in that particular direction we're going. Uses a patch antenna, as you see here on the left, and the unit itself is extremely small. It measures 6mm by 8mm. We take the GPS coordinates and we feed them into software that produces a voice from those coordinates. Originally, this coordinate to voice firmware was on a separate microcontroller and started off as a prototype looking like this. The software was soon deployed and tested, and it was miniaturized and landed up looking like this, complete with the transmitter. As you can see from the diagram above, we've incorporated the GPS data to voice onto the main micro, and it runs in the main firmware, thus miniaturizing even further the GPS to voice firmware. The transmitter, the SSB transmitter, is fed and controlled by the main micro and gets information in audio to go into the SSB converter. The audio is in digital form directly from the microcontroller. The whole transmitter with the GPS to voice is housed on this very small board, 20 by 30 millimeters. It includes the ATU and the 1 watt power amplifier. All are included on this tiny little board, which has now been integrated specifically for LALELA. On MXB-1 and MXB-2 we had specific problems with antenna polarization. The large hole at the end of the wire antenna, although automatically tuned and exactly in phase, gave us problems. We had to shift the phase angle of the antenna currents in order to fill in the hole at the bottom of the antenna. Otherwise, it was a case of driving 43 kilometers in a hurry to get the initial data as the balloon ascended. Producing hydrogen on board was going to be a difficult problem, but turned out to be very sophisticated and much simpler than we originally thought. It started off life looking like this, and soon developed quickly to look like this. Sometimes we get some big surprises. We have enough hydrogen on board to last us for 600 days. The next function is the battery and its current sensor. On the micro we record the amount of current put into the battery and the amount of current being taken out of the battery. From tests on the bench we found out exactly what the efficiency of the battery is. We actually, in our telemetry, download this efficiency. And in MXB3, one of the principal tests will be to find out exactly how this battery operates in the cold, high altitude temperatures of 22 kilometers. We think we may have a problem. For you, it's very, very accurate, and its digital output can discriminate 0.1 of a bar and is excellent for our particular function. We've had great success with this sensor and remark on its reliability and accuracy. The ice detector. This is the result of different measurements taken on the wind turbine. We know the RPM, we know the current, we know the voltage. From this we can detect quite quickly if we have an ice buildup on the bearing. Once we have this ice buildup, we take certain action to overcome it. Automatically, the microprocessor will handle the situation by feeding energy from the turbine back into its windings, which are quite close to the bearing, and this removes the ice. We use the I²R losses of the wind turbine as a de-icing heater. Now we have a funny little block up here on the left-hand side which says destroy RX. To conform with the requirements of other countries who feel that we make inferior equipment who may go spurious and give them problems. We have a VHF encoded destroy receiver that will destroy Lalila, send her into pieces and bring her down to the ground, switching her off permanently. We have no intentions of using it.
That was part of a video that was made for the AMSAT conference. They are about to fly MXB is the balloon experiments that they do. There are 5 in the project, so 3 is due any day now. That will prove the battery, and then they're going to. We hope that before the end of, or by the end of the year, we should have gone through all the ones, and then MXB5, which is the final one, will then hopefully fly. What's interesting to us is that a lot of the developments that are taking place for this particular project will also have a lot of application in our future CUBESAT program. So there's a lot of interesting developments taking place in that particular field. Well, I won't say much more about it. I guess you've got to watch the AMSAT website, SA AMSAT website, for developments on Lalila when it's about to happen. So hopefully we've caught up a few minutes. Thanks very much.
Any questions quickly for Hans about the Southern Africa operations and activities? Yes, Michael, at the back.
On the balloon, when it's floating along, will there be any wind? Because if it's floating along, then by definition it's going at the wind speed.
Yes, but what they've calculated is the way the balloon floats along. Apparently, there's still a difference between the height and where the turbine is, and calculations show that the turbine will deliver enough speed to be able to charge the battery and keep the hydrogen topped up. But it's a question we also have. But we spoke to a lot of the sort of the weather fundies that know more about upper air winds, and they believe it will. So yeah, good question. We'll hope it does.
Okay, thank you. Certainly in the UK we're having lots of fun. There's lots of students build it using weather balloons which are going straight up and popping and coming down, but there's lots of radio data that they're producing almost on a weekly basis. So if you want to know what the temperatures and pressures and humidities are at that sort of height, whether there's actually a risk of ice or whether it's so dry there is no ice, there's a lot of UK recent experience.
The problem is you won't get a balloon, weather balloon to go up 22k.
We'll talk about that, but I've tracked them up to 29k, but okay, enough time. We've run out of time completely. We should be in the middle of the coffee break now. I apologise that we're still 6 or 7 minutes late. If you could aim to be back here by about 10 past 11 at the latest, we'd be very grateful. Thank you. Thank you again, Hans.